Okay, hello guys. So this is example 2. If you realize there's a working there because I already recorded this working step by step before, but suddenly I realized that I haven't opened up, I haven't switched on my microphone, so I have to do this again. So never mind. Uh, yeah, I did for example 2 and 3, so I didn't switch on my microphone. So yeah, never mind. Forgive me. Okay. So in this example 2, as you can see, that now we have an irreducible quadratic factor, which is this one, because this one cannot be factored into two linear factor there. So that's why we call it irreducible quadratic factor. I mean, sometimes you could have irreducible quartic and so on, depending on the question. So it's not necessarily x square quadratic factor here, but most of the time I think if involve cubic, you could at least be able to factor one linear factor out of it. Okay, um, so what you do now, again, you're going to write down this a linear sorry, it's a constant there over a linear factor, because again the numerator, remember, 1 degree less. So if the denominator is linear, so on top you must have a constant. So in this one you're going to have um, linear expression on top as a numerator, because 1 degree less compared to the denominator. So next, what you do, here I just consider uh, the numerator part, because bear in mind that I'm assuming that you understand that the reason a multiplied by this x squared plus 3x plus 5, because to make the denominators the same, because you kind of like actually having this x squared plus 3x plus 5 here, multiplied like that, and x minus 6 there. So because the denominator is the same on the right and on the left hand side, so I just consider the numerator there. So having this expression, okay, so having this expression, so I can see that here, if I put x equals to 6, so this thing will be 0 here, because 6 minus 6 is 0, and multiplied by this term, I have 0 here. Okay, so you let x equals to 6. So when you do that, you substitute on the left hand side, so 6 here, and 6 here, 6 here, and 0 there. So you will be able to find a, and you will find out a equals to 4. Okay, so again, after that, after you have found a, and then you start to realize that what should I substitute next. I mean, I already have x equals to 6. Then whenever you cannot see what is the value of x that you should substitute in next, so always consider x equals to 0. But it might not always work, but most of the time that is the first value of x that you consider, 0 and 1. Okay, 0 and 1, you could have substitute any value of x, but depends on that. If you substitute, I mean, you just pick randomly, you might end up with the terms, the expression of, sorry, the equation consisting a, b, and c together, which is rather difficult to solve. Maybe you have to do simultaneous equation and so on and so forth. So pick your x wisely. So in this case, I'm going to pick x equal to 0. So if you do that, you can see that immediately the left hand side, which is 7 square plus 2 times 0 square minus 28, so you just have negative 28 here, and this one 0 0 0 here. Then you can see I substitute at a equals to 4, the value that I just found just now. So the b terms gone here, so I have the c times negative 6. I have negative 60 here, so c, I will get c equals to 8. So again, after you find that, you substitute the next value of x. So 1 you can put 2, you can put 3. So 1 is easier because everything just multiplied and become itself. So 7x squared, so 1, so you have 7. So you do that, then you will get b equals to 3. So there you go. Now you just substitute back your value in the form, so you have that. Okay, so so let's see what happen if you have x squared plus 2x minus 28 uh, minus 28 here. Okay, I think I will cover that in the next example. Okay, so sorry. Okay, so I'll just keep it in the next example. All right, that's it for